Okay, so the first 3 questions on the test are actually review of Chapter 1, absolute value. So do 1 equation, 1 greater than, 1 less than. Okay, and your equations will be like this, okay? Meaning there's another kind of equation when you have a variable outside and inside, and you got to worry about the extraneous. I'm not directing you to those problems when you go to the study guide. It's just the ones that are pretty basic like this. Remember the steps for solving absolute value equation? What was the first step? Isolate, right? This one doesn't have to be isolated. But you always, if there is anything to be taken away from the absolute value on that side of the equal sign, you want to do that first. So step 1 would be, make sure that I'm the right thing, isolate. Isolate. All right, this one is already isolated. Okay, what was the second step? 2 equations, right? For an equation, absolute value equation, break it into 2 equations. And what would they be? Right. If what's inside here equals 15 or negative 15, this thing is solved, right? Because when you take the absolute value of a negative 15, it's 15. So that's your 2 equations. Just break it into 2. Right? Neither one of these 2 has an absolute value anymore. The whole point of doing this is to get rid of the absolute value symbols. X plus 12 equals 15. X plus 12 equals negative 15. Solve. X equals 3. X equals negative 27. Is there a third step? You could check, right? Which is a little more important if you had the variables inside and outside, then it's definitely something you need to do. But in this one, you don't have that. It's still a good idea to check. Check. Right? 3 plus 12 is 15. Negative 27 plus 12, negative 15. Both check. We're good. Ashley, are you good? Okay. Ashley. Okay. Okay, how about an absolute value less than? What's the first step? Still we isolate, right? Okay, this one we have to do some isolating. What do we have to do? Subtract the 7, right? So remember, you can never do the math with the absolute values in this. So don't try to do negative 2 plus 7, right? Can't do it. Right? We subtract 7, subtract 7. So absolute value of 3x minus 2 is less or equal to 11. Okay? What is the step that breaks down the absolute value or undoes 3-part inequality? For a less than, 3-part inequality. Right? 3-part inequality. Okay, what will it be for this one in particular? What are the 3 parts? What goes on the left? Negative 11, right? Take that positive 11 and put a negative over here. So it's like this. Less than or equal to 3x minus 2, less than or equal to 11. Right, that's the 3-part. It's telling you that this expression, which is inside, is in between negative 11 on the left, positive 11 on the right. Now, could you write it as 2 inequalities? Yes, you can. You could say 3x minus 2 is greater than or equal to negative 11, and it's less than or equal to 11. And you'd have to include the word and then make sure that you're counting the part where the graphs overlap. That is implicit in a 3-part inequality. And this is the way the math people do one of these. They don't do it with two-part inequalities. They do it with 1 3-part. Okay, now how do you solve it when it's got 3 parts? You isolate the variable in the middle, right? So first step would be add 2. So remember to do it in all 3 parts. So negative 9 is less than or equal to 3x is less than or equal to 13. And divide 3, divide 3, divide 3. So what we're left with is negative 3 less than or equal to x less than or equal to 13 thirds. Negative 3 less than or equal to x less than or equal to 13 thirds. Okay. Solve and graph. Right. So now let's graph it. Okay. So I mean, you could get wrapped around the axle about where am I going to graph 13 thirds, but in the end, all you really need to put on here are two values, right? You need to put the negative 3 will go here, and 13 thirds, which is 4 1/3, is good like it is. I mean, you don't have to give any marks in between. Just say that. Right. Now, the graph is going to be circles and shading, right? What kind of circles are we going to put on both of those? It's going to be closed, right? Because the or equal means that those are part of the solution. So let me go like that. Closed and closed. And then where is the shading? In between, right? Again, that's a three-part inequality. It's telling you that the shading should go in between negative 3 on the left, 13 thirds on the right. That's what this is saying. So shading. Cool. That is recording. Okay, we're ready? Okay, absolute value greater than. What is the first step? Isolate. Good. You guys are all over the isolate, which is good because it comes up in other kinds of equations. That's also the first step, like radical equations. Isolate. Okay, what do we have to do to isolate the absolute value on this one? -6 and divide by 5. And which one are you for sure going to do first? -6, right? I mean, you could do the divide by 5, but if you do it, make sure you divide everything by 5, not just this and this, right? You would have to do this too. Most of the time when I see students do that, it leads to something not good. So I would definitely do the -6 first. So now we got 5 times absolute value of x plus 1 is greater than 15. Right? How are you going to get rid of that 5? Divide, right? It's a fairly common mistake at this point that students subtract. And I don't know why. I think if I asked you what operation is going on there, you'd say it's a multiply. So definitely it's a divide. But I see a lot of like -5 over there. So divide. So what does this look like? X plus 1 greater than 3. Okay, now we've isolated. What's the second step? 2 inequalities, right? 2 inequalities. Okay, what are they? X plus 1 is greater than 3, right? And what's the other one? Or x plus 1 is less than -3. And that's not complete unless you include what word? Or, right? It's an or compound inequality, meaning for the whole thing to be true, meaning this statement right here, just one part of it has to be true. It doesn't have to be both of these at the same time. So we really should have this word right there, or. Okay, solve. Subtract 1, x is less than -4, or x is greater than 2. Graph. So our 2 goes here, our -4 goes here. Should this one have open or closed circles? So it should be open because both of these are not or equal to, right? They're just less than or greater than. So we're going to go like this. Open, oops, and open. Okay, where's the shading go? For x greater than 2, right? Just think the x is the shading, okay? The shading is greater than. On a number line, where's greater than? To the right. So the shading is to the right of 2. And for the x less than negative 4, the shading is less than, which is to the left of negative 4. Okay, so that's the graph. Okay, then we got into in the beginning of this chapter, we did domain range function. So if you have a graph of points, which you will, how do you tell the domain? It's the values of x, right? And the directions, like these here on the test say, put them in order from least to greatest and don't repeat, right? So domain, especially when you've got them like graphed, in order to know the x values, you just have to like start over here. What's the x value? Negative 4, right? It's 4 to the left. So negative 4, negative 2, 0, 1, and 2, right? And the no repeat part says don't write 0 twice, even though there's 2 points at 0. So we're going to say negative 4, negative 2, 0, 1, and 2. That's the domain. Okay, how about the range? Okay, the lowest y value is negative 2. Negative 1, 0, 1, 2. And don't write it twice, even though there's 2 points. Negative 2, negative 1, 0, 1, 2. Okay? Does that collection of points represent a function? How do you know? Say again? Yeah, you've got one x value that has 2 y values, right? When x equals 0, y is negative 1. When x equals 0, y equals negative 2. And the definition of function is you can only have one y value for each x value. So when you see that, right, that thing right there means not a function. Okay. Right, that should be an easy problem for you. Okay, then you have one which is a set of points. Same question though. Domain, range, function. What is the domain of this one? Again, putting them in order from least to greatest and not repeating any values. The domain is negative 3, 0, 1. What is the range? Negative 2, 4, 5. Okay. Is it a function? And what in there is 2 x's that repeat, right? So these 2 right here, repeated x values means not a function. I mean, is it a problem that you actually have repeated y values? No, that's okay. You could have every x could have the same y value. That's a constant function, right? So repeated x values means not function. You got repeated y values, okay. It shouldn't be hard. Okay, let's go to evaluating functions. Right? If you have a function given by the function notation f of x, right? How do you find f of, in this case, 5? How do you evaluate the function for a number? You just plug it in the place of x, right? So f of 5 equals And now in the expression on the right, just like we evaluated expressions in chapter 1, put a 5. Negative 3 times 5 plus 2. Negative 15 plus 2. Negative 13. What point does that represent? What xy point is that? 5, negative 13, right? The f of x is like the y, right? So that is 5, negative 13. You ready? Okay, find the slope. It's kind of like the quiz question, really. You know, find the slope. What are we going to do so that we can read the slope right off the equation? Solve for y, right? So this will be negative 4y equals negative 3x plus 12. Then what? Divide by negative 4, divide negative 4, divide negative 4. Y equals, okay, the negatives cancel, right? Don't leave it as negative 3 over negative 4. You lose points. You got to say that they cancel each other out. 3/4x minus 3. Okay, now answer the question. What is the slope? 3/4. M equals 3/4. I think this test would be too easy for you guys. But that's okay. Yeah, next chapter, I would say the degree of difficulty goes up quite a bit. This is supposed to be review. It seems like most of you guys actually did pretty well when you learned this the first time, which is good. Okay, what if you've got 2 points and you have to find the slope? Okay, we have a formula for that, right? y2 minus y1 over x2 minus x1. Right, it's the change in y divided by the change in x. So 6 minus negative 2, 1 minus negative 3, which is 6 plus 2 over 1 plus 3, which is 8 over 4, which is 2. Right, just be careful that you're doing the y's over the x's and not the x's over the y's. Okay. Okay. Graph a line. Again, this could have been a quiz question, right? Graph a line which is already in slope-intercept form. The first point is the 1/2, right? The first step would always be to do that right there. 1/2 right there. And then use the slope to find another point on the line. Okay, well, the slope, you know, I've written it because this is the way I'm sure on the test it'll look the same way. Because, you know, if you use like an equation editor of some kind, they're going to put the minus in front of the fraction. It won't be like obviously in the numerator or the denominator. It'll be in front of the fraction. So this negative 3/2, right? Negative 3/2, negative 3 over 2. You could consider it to be like negative 3 over positive 2, or you could consider it to be 3 over negative 2. I mean, you need to put it somewhere so you know whether you're going up or down, left or right. So let's see. If we go negative 3 over positive 2, that means down 3, right 2. Down 3, right 2. right? If we go positive 3 over negative 2, that would be up 3, left 2. But whichever way you do it, it's the same line. Okay, Natalie? Okay, then we learned another form, which is called standard. What is unique about the standard form? Yeah, the x and y terms, which I did wrong, are on the left. The constant term is on the right. Now, if you graph this by solving for y and doing slope-intercept, that's fine, right? But there is another way to do it, right? Because it's in this form, it's very easy to say, for the x-intercept, cover up the y term, and what's left? 4x equals 12. X equals 3. Okay, for the y-intercept, cover up the x term. 3y equals 12, y equals, okay, so those are your intercepts, right? At x equals 3 and at y equals 4, right? And just to be clear, right, you cannot write that like 3, 4. Not the same thing, right? This point is 3, 0. At this point is 0, 4. They don't go together in one point as 3, 4. And then draw the line. You know, if you solve it for y, you'll automatically have the y-intercept, right? That'll be right there. But the question does say find the x-intercept too, so you still need to find that, however you do it. Okay, now we've got another form of a line. That makes 3, right? Slope-intercept, standard. This is the last one, point slope. Point slope looks like y minus y1 equals m times x minus x1. Right? So given a point and the slope, give a point slope equation of a line. What do we have to do? Just plug in the values that we were given, right? Just like the homework problems like this. It was very straightforward. Just put in the 2/5 goes here, the -1 goes here, the 3 goes here. Or sorry, yeah, the 3 goes there. So y minus 3 equals 2/5 x minus -1, which is x plus 1. And just leave it. It says write it in that form, so you don't have to do anything with it. Just leave it like that. Good? Hunter? Okay. Natalie? Okay. Okay. What if you don't get a point in the slope? You get 2 points. Find the slope first, right? If you don't have a slope, find the slope. So our first step will be, these 2 points are the same 2 points I used before, right? It was m, it'll be m equals 6 minus -2 over 1 minus -3 equals 8 over 4, which is 2. So now we have 2 points in the slope. Do we have a 2-point slope formula? No, we don't. So we're using the same one, right? We use this one. Y minus y1 equals m and x minus x1. Okay, so we've got the slope. That is unambiguous. Which point do we use? Does not matter, right? But depending on which one you plug in, it would look different at this point. But the question says write it in slope-intercept form. So you're going to plug it into this and solve for y. So no matter which point you use, when you solve for y, it's the same thing. So I'm going to use the 1/6 because that looks a little easier. Right? Y minus 6 equals 2x minus 1. So you put it in, and then solve for y. Y minus 6 equals 2x minus 2. Add 6. Y equals 2x plus 4. You ready, Curtis? Okay. Okay. Then we've got the parallel perpendicular. So it says write an equation, its slope-intercept form, of a line that's going through the point -1, 3, and it's parallel to this line, right? What piece of information are they trying to tell us by saying that our line is parallel to this line? The slope, right? And we know about parallel lines, they have the same slope. So we're trying to find the equation of a line that goes through that point and has a slope of 2. Okay. Now, it also says put it in slope-intercept form. So it's not like a couple slides ago where you just left it in the point slope. You'll need to substitute. Y minus 3 equals 2x plus 1. Y minus 3 equals 2x plus 2. Add 3. Y equals 2x plus 5. Just make sure you read the directions. You know, if it says put it in slope-intercept, put it in slope-intercept. Good. Shana. Okay, now we'll do perpendicular. Okay, what piece of information are they telling us? That our line is perpendicular to this line. They're trying to tell us the slope indirectly. Okay, what do we know about the slopes of perpendicular lines? Inverse reciprocals. No, say that again. They are opposite reciprocals. Inverse and reciprocal means the same thing, right? They are opposite sign, flip the fraction. So what is the slope of our line that's perpendicular to this line? M equals positive 5 over 3. Right? That was just a clue. Now we know the slope. We already know the point. We use point slope form again. Y minus 2 equals 5/3 x minus 2. Y minus 2 equals 5/3 x minus 10/3. Add 2. right? Y equals 5/3 x. What is it? Negative 10/3 plus 2. Say again? Close. Negative 4/3. Right? It's plus 2. So 2 is 6/3. So negative 10/3 plus 6/3 is minus 4/3. We're good? Okay, we're getting there. Okay, write the equation of a line which is through the point negative 3, 4, and it's vertical. How do you write the equation of a vertical line? How do you say again? Vertical line. What is the equation for it? Come on. It's x equals. Let me just think of it. Let me do this. I'm just going to draw it on this graph, right? If I have a vertical line here, then what is it that's the same for every point on that line? The x, right? X equals 2. Every point in that line has a x coordinate of 2. It's 2 to the right. So the equation is x equals 2. Right? Now, in our problem, our line is going through the point negative 3, 4. What's the equation of the line? X equals negative 3. Because if that's the x coordinate for that point, it must be the x coordinate for every point. X equals negative 3. Okay, what about the equation of a horizontal line through 4, 1? Natalie? Is it going to be x equals or y equals? Y equals 1. Right? Because if it's a horizontal line, right, it's going through 4, 1. 1, 2, 3, 4, 1. It's a horizontal line through that point. Every point on that line, y coordinate is 1. Y equals 1. Almost done. Okay, these are the directions on the test too. Describe the transformations and sketch the graph using the transformational approach, meaning understanding the parent function as a v, opening up vertex at the origin, and then just shift it around. I don't want to see any table of values plotting points. Right? Show that you understand the graph. What are the transformations in this equation? Okay, left and down. And what does a minus do in front? It's a flip. Okay, so let's draw that. Left 3, down 1. Left 3, down 1. And it's flipped. And there won't be any stretches or compressions on the test. It'll only be these kinds of shifts or transformations. There'll be 2 like this. I think there's 19 questions. Although you guys have an extra credit too. What's that? Oh, I'm not going to tell you that. It's going to be prove the theory of relativity. No, I won't do that. Are we ready? Not quite. There's one more slide. Yeah, it's pretty much, yeah, I'm giving you a preview of everyone except the extra credit. Although the extra credit relates to something else on here, but that's all I want to say. Sure, go ahead. Okay, one more. Are we ready now, Curtis? Okay. And it's the write an equation. Given the graph, write the equation. Okay, so what transformations do I have to include into my equation? It's right 1, down 2. How do you show up right 1? X minus 1 inside the absolute value is right, right? Right. And then how do I show it down 2? Minus 2. Up. So y equals x minus 1 minus. That's it. Sandy, you okay? Are you okay? Sure. It's my fault, not your fault. Okay. So the study guide. Again, you don't have to do every problem, right? But you should do some in each group because they're similar to a test question, right? And if you don't see something represented there, it's because they're not on the test. There are things I didn't put on there. Let's see. These in parentheses here is just one group. It just I'm trying to skip over the ones that were stretches or compressions because we didn't do that. That's not on the test, right? Even though you guys actually know it. They're not on the test, so I'm directing you around those. You hand it in for extra credit before the test. If you fail the test, which I'm hoping nobody does, but if you do, and if you did a study guide, got full credit, you can do a retest. But I was very liberal the first test to break that policy, but I will not break that policy this time. Prepare or not. Yeah. Sure. And you can borrow graph paper if you want. Yeah. Okay. Does anybody have any questions about this? Expect many parents coming tomorrow night? Yeah. I like the back to school night, really.